All right, so let's talk about water quality. So hopefully you've watched the water quantity video. You can watch them in either order. So let's talk about quality just a little bit. So water is colorless, tasteless, odorless on its own, but it's a great natural solvent. So it's really easy to dissolve things in water. So as a result, we need to think about what we want dissolved in water and what we don't want dissolved in water, right? That's basically what's going on in water and wastewater treatment, is what should be there and what shouldn't be there, basically. So whenever we talk about contaminants or impurities in water, these are either dissolved or suspended materials that get into water. So again, they can be dissolved or they can be suspended. Sometimes your textbook calls it impurities. I will probably say contaminants quite often because that's the term I'm used to. But basically it's anything in water that isn't water itself, right? So take a second, pause the video. How would these impurities get into water? Just pause and think about it for a second and try and see if you can answer that. So impurities are going to get into the water through the hydrological cycle. So the hydrological cycle is this idea that water does not just magically appear, right? We can't create or destroy matter, that kind of good law, right? First law of thermodynamics. And water is going to move through the entire earth. So we have lakes and we can have evaporation from those lakes. We can have condensation of that water in the air into clouds. And then we can have precipitation, and precipitation can run off into water. And so water is always moving. It's moving through the land, the atmosphere, and bodies of water itself. So as this water moves, it's going to pick up impurities or contaminants, and those kind of those properties of those contaminants are different based on where they come from, and they're going to be different based on different geology, different climate, all that good stuff. So the other thing that I want to make sure that we talk about briefly in this pre-lecture before we get to class and we get into the chemistry of water quality is the difference between groundwater and surface water. So if you've taken a class where we've talked about wells for a long time, those are groundwater sources. So groundwater wells are typically what we think of as our groundwater sources. So it's water that's, as the name suggests, underground, right? You can't see it. It could be in an aquifer, could just be in a bore well itself. Surface water is, as the name suggests, anything that's on the surface. So we've got rivers, we've got lakes, all sorts of types of surface waters that we can potentially have. And what you'll notice in the middle on the bottom of this slide is there's another category that we call groundwater under the direct influence of surface water. So some groundwater sources, by the virtue of being very close to a surface water source, that surface water can leach through layers of rock and soil and potentially leach into a groundwater source. So there are some groundwater sources that could be under the influence of surface water depending on where they're located. So there's a little bit of gray area between the two. But generally when we talk about water sources, we talk about groundwater versus surface water. And just to put this in perspective with that little diagram that I like to show, right? Your surface waters are right up top, right? They're where the water comes from and hopefully where your treated wastewater goes at the end of the day. So I'll show you a couple other visuals related to water sources because I think it's good to have a couple of ways of looking at this, right? Surface water is going to be at that same surface as the land surface many times, right? And so we have what we call the water table line, which is basically that same line is where the surface water is, and anything below that is going to be the groundwater. So this is just another way of looking at how these two things are different. And then I like this little infographic that I found online. So surface water, again, water on the surface, such as streams, lakes. We have aquifers, they're underground water sources, basically water-bearing permeable rock. And I'm not a geologist, so there's different types of permeable rock, and based on the types of permeable rock, you can have different contaminants. And then we have groundwater, right? Water that saturates soil, sand, rock beds, and it supplies springs and wells. So surface water, groundwater, two things that we care about. So when we talk about water quality and we talk about impurities, they're different when they're in groundwater and surface water. So a couple questions on this slide. So take a second to pause and try and answer these by yourself. So the first question is, what types of impurities does rainwater pick up as it falls to the ground? And then what types of impurity does runoff pick up as it moves across and soaks into the ground? So take a second, pause, think about that. And if we're talking about impurities that rainwater picks up, these are going to be things like pollen, dust, and dissolved gases. So things like oxygen, nitrogen, carbon dioxide, sulfur dioxide, that can all be in your rainwater as it's falling to the ground, right? So we're coming from the atmosphere down to the surface of the planet. And then if we're talking about runoff, as water moves across the ground and soaks into the ground, we can pick up silt, clay, soil, vegetation, bacteria, microbes, pathogens, waste products, weathered minerals from rocks. So as we permeate down through rocks, we can pick up specific chemicals there as well. And so what you'll notice here, when it comes to these types of impurities, is many times in surface water, this is a lot of suspended materials. Some of them will settle out just by virtue of gravity, but microorganisms also grow and die in surface waters in a really fast way, so they can add impurities to water. In groundwater, we typically see more dissolved minerals because we're percolating that water down through rocks. So we'll see things like manganese, arsenic. In Appalachia, they were talking about mine runoff. That's going to be much more common in groundwater sources in many cases. So we've kind of already hit this point earlier in the lecture, but our impurities are going to be classified as one of two things. They're going to be dissolved impurities or suspended impurities. So generally, surface waters are going to have more suspended impurities than groundwater because groundwater is naturally filtered through soil. So as that water moves through the soil layers, all of those suspended particles are going to get stopped by sand and soil. And this is actually how a sand filter works when we talk about those later in class. But take a second, last question for yourself in this lecture. Pause and see if you can come up with some ideas for dissolved impurities and suspended impurities. What could they be? So dissolved impurities can be things like cations, anions, organic compounds, and dissolved gases. So they tend to be smaller particles if they exist, and they're things that really undergo aqueous reactions very well. So they react in water well. Suspended impurities are going to be things like silts, clays. Like if you look at like a really muddy river, right, that's a suspended impurity, that's silt. Organic and inorganic colloids, so those bigger particles that we talked about, right, they have a large surface area. And then things like living organisms, bacteria, algae, protozoa, and viruses. Those are going to be suspended within water. So in class, we'll talk in more detail specifically about specific contaminants and impurities, but I want you to understand the difference between dissolved and suspended, and then the differences between surface and groundwater at the end of this pre-lecture. So we'll talk more in class specifically about water quality chemistry.